Hi students, good morning all. Myself M.M. Dikshit sir. Our today's point is the third point in this application. So write down our part first is the circular motion. This is our part first, circular motion, in which fourth point is about the application, and in the application it is a third point, vehicle on the banked road. Vehicle on the banked road. This is our third application. Vehicle on the banked road. And in this application, we shall consider different points, such as first point is about the necessity of the banking of roads. Second point is the what is banking of roads and angle of banking. Next point is about the most safe speed, and other points are about the angle of banking and speed limits. That means in this point we shall consider number of points. So write down here first point in the point third. This is our first point in this third point. 3.1 first. Necessity. Necessity is our point. Necessity. In which the question will be asked as, write down this question, explain the necessity of the banking of roads. Explain the necessity of banking of roads. This is our point. Sorry, this is our question in this point, necessity. Now, before going to the banking of roads, let us see first the necessity of banking of roads. म्हणजेच बँकिंग ऑफ रोडची काय आवश्यकता आहे किंवा का आवश्यकता आहे. Now we know that on the horizontal circular track the expression for the maximum speed is given by v is equal to square root of mu s into rg. So write down the expression for the maximum speed the expression for the maximum speed on the plane horizontal curved road is v is equal to square root of mu r G. Now this is an expression for the maximum speed on the plane horizontal curved road. Because it is our common experience that if I asked you to take a turn by using a bike on the ground, and if the surface of the ground is changed, sometimes it is grassy surface, sometimes it is glass surface. Now it is our common experience that if the glass surface is used instead of grass surface, then we have to take a slow turn, and it shows that the maximum speed depends upon the number of factors such as friction, radius, etc. And by considering these factors, this expression is made. V is equal to square root of mu rg. And this expression shows that the maximum speed depends upon only force of friction, because at the given road the radius and acceleration due to gravity is constant. So the maximum speed only depends upon the force of friction. That means on the nature of the surface of the road. If the road surface is rough, then friction is more, and so maximum speed is more. But if the friction increases, that means rough road is used, the wear and tear of the tires increases. Also, the force of friction is not always reliable. Why it is not reliable? Let us see first the increase in friction what causes. So write down, it shows that 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 increase in friction causes wear and tear of tear means टायर बस्ट होणे, टायर फाटणे, खराब होणे. वियर म्हणजे झिजणे. वियर अँड टियर ऑफ द टायर्स, wear and tear of the tires. And also, if the road is wet due to the rainfall or due to the fall of oil or diesel on the road, the friction does not provide the necessary centripetal force, and so the vehicle may goes off the road. So write down, also if the turn is sharp, and if the turn is sharp and a road is wet, if the turn is sharp and a road is wet and road is wet, comma, then vehicle may goes off then vehicle may goes off the road therefore may go off the road due to skidding. So in order so in order to in order to avoid, please prepare your notes while watching this video. So write down simultaneously. So in order to avoid the danger of an accident. So in order to avoid the danger of an accident, some other arrangement some other arrangement some other some other arrangement is made some other arrangement is made called as some other arrangement is made called as banking of roads called as banking of roads. In this way we completed the answer of the question, necessity of the banking of roads. Now the next point is the banking of roads, and it is the second point in this application. So write down it is our part first. Fourth point is about applications, and third is for the vehicle on the banked road, in which it is our second point, banking of roads. Banking of roads. And the question will be asked on this point as, what is the banking of roads? What is the banking of roads? What is banking of roads and angle of banking? And angle of banking. What is a banking of roads and angle of banking? And angle of banking. So after the point necessity, we are going to understand what is meant by banking of roads. Now, in order to take a turn with a maximum speed, that means in order to increase the maximum speed of a vehicle along the curved road, the surface of the road is kept inclined. That means if it is horizontal plane surface of the road, it is kept inclined in such a way that its outer edge is at higher level than the inner edge. Its outer edge is at higher level than the inner edge. And this arrangement is called as a banking of roads. So write down, in order to increase the maximum speed, in order to increase the maximum speed on the curved road in order to increase the maximum speed on the curved road, the surface of the road the surface of the road the surface of the road is kept inclined is kept inclined in such a way that its outer edge its outer edge is at higher level than the inner edge. Write down the answer of this question. What is the banking of roads? In order to increase the maximum speed on the curved road, the surface of the road is kept inclined in such a way that its outer edge is at higher level than the inner edge. Now, let us see in this figure how the banking of road is made. So, draw this diagram. This is a horizontal direction. So right here, horizontal direction. This is outer edge. This is inner edge. And this is a banking of a road. So write down this theta as a angle of banking. Draw this diagram. And after this diagram, let us define the angle of banking. So, write the point angle of banking. Angle of banking. And it is denoted by theta. Angle of banking, and it is denoted by theta. This is our next point. So, from the diagram, it is clear that what is meant by angle of banking. The angle of banking is defined as the angle between the surface of the road along the curve and the horizontal direction. So, write down the angle of banking is defined as the angle between the surface of the road along the curve and horizontal direction and horizontal direction. So write down this definition. The angle of banking is defined as the angle between the surface of the road along the curve and horizontal direction. And the next point is most safe speed and angle of banking. Let us remember the word most safe speed, in which we require safe speed, not maximum or minimum, and therefore it requires a safe speed instead of maximum and minimum speed, and so a vehicle may negotiate or vehicle must negotiate a turn with a safe speed on the curved road. So write down the point. It is our third point in this main application. So write down here. Fourth point is application in which it is a 3.3. Most safe speed, most safe speed and most safe speed and angle of banking and angle of banking. It is our point. Most safe speed and angle of banking. The question will be asked on this point is also VIMP question. So write down the question. Derive an expression for derive an expression for the maximum most safe speed, most safe speed, underline this word, most safe speed. Derive an expression for the most safe speed on the curved road which is banked. On the curved road which is banked. This is our VIMP question, and we already know that the answer is expressed in 4 points. First point is consideration, second point is a diagram, and its a third point is notation, and fourth point is a main point. So write down the answer in which it is our first point. And we know that first point consideration is always made from the question. In the question we have to obtain most safe speed on the curved road which is banked. And so consider a vehicle is taking a turn on the curved road which is banked. This is our consideration. Write down. Consider a vehicle is taking a turn on. 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 turn on the curved rod which is banked on the curved rod which is banked curved rod which is banked. This is our consideration. We know that this consideration should be shown by using a diagram. This consideration should be shown by using the diagram. So, draw the diagram. This is a horizontal direction. This is the inclined surface of the road on which vehicle is shown here. These are the tires of the vehicle. Suppose that this is a vehicle and this point is its a center of gravity. So from the center of gravity, let us draw a vertical line. On that line, represent the weight which is always directed vertically downward, and then this is a horizontal component of the normal reaction, and please draw the normal reaction perpendicular to the road surface and complete here a parallelogram along the diagonal. Draw normal reaction. This is n cos theta and this is n sin theta. This is the banking of angle of banking. Draw this diagram properly, and after the diagram, draw this diagram properly. Then after a diagram, let us denote the notations of this expression. Notation of this expression. Let comma m, mass of vehicle, mass of vehicle, or radius of curve or curved road, radius of the curved road, theta, angle of banking, angle of banking, theta, angle of banking, n, normal reaction, perpendicular, normal reaction perpendicular to road surface. See this in the diagram. The normal reaction should be perpendicular to the road surface shown in this diagram. So draw this normal reaction perpendicular to the road surface. And the fourth point of this answer is a mathematical part or mathematical expression. Let us split the normal reaction, write down Let us split the normal reaction capital N into two rectangular components, into two rectangular components, into two rectangular components. Write down in which let us see the figure, in which the horizontal component in which the horizontal component, see this component in the figure, it provides, horizontal component provides the required centripetal force, in which the horizontal component provides the required centripetal force. And from this discussion, we are able to express a formula or equation. So write down the equation from this discussion. Centripetal force is mv square upon r, and it is provided by the horizontal component n sine theta. Write down it as equation number 1. Let us see the figure from which the weight is balanced by the vertical component. So write down, and the weight of the vehicle is balanced by and the weight of the vehicle is balanced by vertical component, and from this discussion, let us form the equation. Weight is mg, and it is balanced by vertical component n cos theta, and it is our equation number 2. And therefore, from equation 1 divided by 2, we get, v square divided by rg is equal to tan of theta, and therefore v square is equal to rg into tan of theta. Suppose that this is our equation number 3. Let us see equation number 3 carefully. It shows that the shape speed depends upon only angle theta, because r and g are constant, and therefore from this made an equation of the shape speed as Vs is equal to square root of Rg into tan theta. This is our main equation. So right here, this is an expression for the most safe speed. This is an expression for most safe speed. And remember that it is not a maximum or minimum speed. It is an expression for the most safe speed. And from equation 3, the expression and from equation 3 the expression for the angle of banking becomes theta is equal to tan inverse of v square upon rg. This is our equation number 5. Write down, this is an expression for angle of banking. This is an expression for angle of banking. And after these equations, write down the important note, and it is our star point. Even if it is not asked, please always write this point. From equation 4 and 5 हे जरी विचारलं नाही तरी लिहायचंच. From equation 4 and 5 it shows that most safe speed and angle of banking is independent on the mass of the vehicle. So it is same for all vehicles, two-wheeler, four-wheeler, or any heavy vehicle. Please attempt this point, because sometimes question will be asked as derive an expression for the angle of banking and show that it is independent on the mass of the vehicle. Then the answer is same, only we have to attach this point.